Okay, just wait. Hello, hello. Please respond, anybody. Hello,
Good
sir.
morning, sir.
Good morning, sir.
Good morning. So we have a PDF on screen. Just already I wrote here clearly, and observe very important definitions. In every theorem we have a just wait. Just what is a measure means? Measure is a length of the interval only. Just observe this one. Just observe this one. What is the interval definition? And starting with neighborhood, closed interval, and open intervals, semi-closed and semi-open. Just observe this one. What is the observe here? Length of. This is the length. Length of this one. Length. This is a. What about this one? The length of. Suppose if a to infinity x greater than a, the length of the interval is infinity. This is also infinity. What is the length is always positive here. Don't write minus infinity to a. What is the length of this one? Is not a minus infinity. Okay, no? Is not a minus infinity. Next one. And one more open set is different, open interval is different, closed set is different, set is set to be open if every C below there exists a open interval. Okay, now open interval is called the open set. Closed set, this is the closed set. Okay. And important is very important is complementation of any set. If complement is equals to the total set minus inverse set minus that set, bounded set. Bounded set. It has any set containing infimum and what is that? Lower bound and upper bound. The total elements of that's in between that lower bound and upper bound. It has two. And one more important theorem. One more important theorem. Let's wait. One more important theorem. Observe here, union of finite collection of open sets is open. Important. Union of open set is open collection of finite collection of open set is union of countable collection of open set is open set. Union of finite collection of open sets. This is a open set. Observe here. Union of countable collection of open set is open. Intersection of finite collection of closed sets. For intersection, arbitrary union. Arbitrary means it has infinite number of intervals are there. Each interval is open interval or open set. Intersection of finite collection of closed set is closed. And intersection of countable collection of closed set is closed. And we have an example. I will give example this one. Intersection of countable collection of open set. Intersection, observe here. Union of finite collection of open, clear. Union of countable collection of open set is open, clear. But intersection of countable collection of open sets need not be a open. And one more thing for intersection, what about union of countable collection of closed set need not be a closed set. And observe here, we have a examples for this one. I will give union of countable collection of closed sets need not be a closed. Okay, no? Need not be a closed. And sigma algebra, failed Boolean algebra. Already we discussed about this one. X is a non-empty set. A collection A is a subset of, is said to be algebraic subsets of simply an algebra, Boolean algebra. It satisfies. We can consider any element, and its complement is also belongs to A. Okay, na? Clearly, A bar is a complement of A in X. That is, complement of a set is again in A. And consider any two sets in a given set of. The union is the union of the any two sets is also in A. Okay, no? This already we discussed about this one. Okay, and let capital A be algebraic subsets. Intersection of two sets again in A. Again in A. By using this proposition, we can prove by using first one. Okay, no? And observe here. Just observe this one. Finite number of in A is again A, and their intersection here. Observe here, especially A1, A2 belongs to N, finite number of sets, and their intersection is also belongs to A. Finite intersection of sets. Okay, no? Next, and again observe here, finite union, no problem. Union of any finite number of set again A, again in A. Again in A. Observe here. Sigma algebra. Just definitions are very well. Sigma algebra. What is the difference? Here difference is sigma algebra, Boolean fit. All are same. And select the what is the set of all subsets of X. There is a collection of what is that set A. Sigma algebra. Observe here, same property, but here involving what is that? Previous one only two sets. Any two sets, select any two sets arbitrarily from the collection of sets, and their union also in that set only. Okay, no? That is a closed. Closed means not a closed set. Closed means their union is also. What about this one? What is the meaning of this one? Second property, arbitrary union of closed set is a. Hello,
sir.
Are you getting?
Yes, sir.
Just listen. That is, A is a closed under countable unions that collect the, what is the difference between algebra and sigma algebra? In algebra, only finite union, and sigma algebra, countable union of sets. Countable, finite is different, countable is different. What is the difference is countable? A natural number set is a countable, and finite is 1 to 300 numbers are there. 1 to n numbers are there. That is a finite. And in the algebraic sets, which is a finite. Here, countable union is closed. Countable union is closed. Sigma algebra subset of is also Borel field. One of the example, power set of X. Sigma algebra. Sigma for any we have a examples. Power set of X means set of all possible subsets of X only. Set of all possible subsets of X. Here observe here, A X equals to A B, two elements. The power set is pi E, set A, set B, and total set. And ABC and containing set power set is set of all possible subsets. A comma A set containing a single elements and combination of two elements and three elements. This is a power set of total possible subsets of X. Okay, now let X be an infinite arbitrary set. A denotes the collection of subsets of X which are finite or their complements are finite. Okay, now which are finite or their complement, that is cofinite. X be a infinite algebraic set. Observe here, cofinite set in topological space. Cofinite topology. Cofinite topology means that set satisfying. What is the set of all? This set is different. Observe here, especially observe here. Observe here, this set is different. This set is containing, what are the sets? The X is an infinite set. These are the subsets of X, and in this case, any set containing in this set condition is A or A bar is finite. You have to complement of this one. Observe here, this set is satisfying. What is that? Satisfying the what is the sigma algebra conditions. Sigma algebra in this set, what is the formation of AR bar? Exactly. What is that? Finite. And observe here, this is called the cofinite set. Is an algebra of sets. And observe here, just wait, and observe here, and prove that we have proof of this one. This set is containing any set. That set should be A or its complement is finite. Anyone. Suppose A is infinite. Suppose A bar is finite only. Okay, now and is an algebra sets of n X. And then prove that A is not a sigma algebra. Underline this one. Okay, now just write down point out this one only. And select the be a sequence of sets in A. And select the sequence A1, A2 up to infinity sets, and such that each set satisfying, what is that? Finite. AN is finite or AN bar. Just write down here AN bar. I forgot here. AN bar, not AN. This is AN bar. Suppose AN is finite, AN bar is infinite. Okay, now thus need not be a finite. Suppose observe AN is a finite. Suppose it's a usually, what is the condition? Any any set is finite. Its complement is automatically infinite. Suppose if you select any one of the AN is finite, so for all n, and their union is also finite. But here clearly, what is that? A bar n is infinite. But what is that? In this set, we don't have any infinite set. Okay, now therefore, since countable union of finite set need not be a finite, countable union of infinites is need not be a finite. Just observe here, need not be a finite set. Therefore, countable intersection of infinite set need not be a finite set. Therefore, if it may be possible that countable union does not belongs to the given set, therefore A is not a sigma algebraic set in X. When the cofinite set, cofinite means any set contains one of the set, the set of all collection of sets, such that the set is a finite set, that set or its complement, anyone is finite. Okay, now note that A equal to P of X, which is a P of X means power set of X only. P of X is a power set of X only. Okay, na? Is infinite nature of X is a necessary condition for the in the above example. And theorem, and observe here. Observe here. They're in sequence of sets. Suppose A is in algebraic sets. The countable sets A1, A2, and so n equal to 1 to infinity is a sequence in A. Then there exists a sequence. Sequence means not in numbers. These are all sets. Okay, no? Bn and n equal to 1 to belongs to such that bi intersection bj equal to empty when I not equal to j, and their union is, observe here, the union of bn equals to union of an. And observe this proof. Given that sequence algebraic of sets, okay, now define the sequence. What is that? Defined like this: b1 equal to a1, b2 equal to a2 minus a1. That means a2 intersection a1 bar. We can write a minus b. What is the a minus b equal to? We can write a intersection b bar. b3 equals to a3 minus a1 union previous sets, or a3 intersection a1 union a2 whole bar, like this. And observe here, just roughly write down this one: b1 equal to a1, b2 equal to a2 minus a1, b3 equal to roughly, and finally bn equals to. And observe that, so b1 b2 intersection, what is the b1 intersection b2? b1 intersection a intersection this set is what is the clearly a1 a2 a3 are pairwise designed, and b1 b2 is also pairwise designed. So we can consider any two. What is that? bi intersection b2, and observe here, A is a closed under complementation and finite intersection. So we get Bn subset. Bn is belongs to the Bn is subset of An, and their union also belongs to this one. Okay, no? So this is the equation one. That means, what is the meaning of A subset of B? What is the meaning? If you consider any element in B which is also contained in A, that is called, what is the B subset of U. Suppose you select let x belongs to union of x belongs to n for some m is the smallest integer, that is x belongs to m. X belongs to m only. Therefore, x does not belongs to a1. X does not be a2 up to a minus 1. We can write x belongs to the am minus their union of this one. Therefore, this is equal to, we can write this is equal to bm. X belongs to m. Your consideration. Therefore, we can consider any element an which is also bn. Therefore, we can write union of an subset of union of bn. Therefore, from 1 and 2, A is if you want to prove any set A equal to B set, both are equal, then we can prove that A subset of B and B subset of A. Therefore, we can write A equal to B. Both are equal. Okay, now arbitrarily first one is given that Bn is always a subset of An. Then prove that select any element. Now we prove that second one. Therefore, select any element in A union of An. And especially that belongs to the union of means any element union of sets. That means x belongs to all sets or some one set. Your selection is, what is that? Any set, some smallest integer x belongs to m. What is the meaning of that one? X belongs to am only. What about remaining previous elements? Previous sets does not contain x. Therefore, x belongs to m. X belongs to a, x does not belongs to a1, and so on. X does not belongs to am minus 1. What about t by x m plus 1, am plus 1? That may be contained, no problem. So therefore by using the this one, x belongs to the am minus a1 union a2 union up to am minus 1. This is equals to, we can write bm. Therefore x belongs to m. Our consideration, suppose x is belongs to the an, which is also in bn. Therefore from one and two we can prove this one. Okay now, and now we prove that. And now we prove that. What is that? Bi intersection. Bi intersection. Bi intersection. Algebraic sets. Already your page number. What is it? Page number 5. Very, very important. Hello, sir. Hello.
Yes, sir.
This is a madam. This is a proof of page number 5. Student, sorry.
Yes, sir.
Okay.
Fourth theorem.
Fourth one.
Is it important, sir?
Important. If any possibility, please send to previous papers to me. Okay, now.
Okay,
Now
sir.
we prove that both are disjoints. Okay, now generally we assume that, and we assume that like this. Okay, now. So just write down ai intersection bj. Ai intersection, what is the bj equals to this one? Ai intersection, and observe here a intersection j intersection this one, and observe clearly a intersection a bar. Generalization for this one. What is the intersection of that set and its complement is always empty set, and empty set intersection is always okay now, is always this one. So and we have bi intersection bj is a subset of bi. What is that? Bi is subset of ai. You can write ai intersection bj, since bm subset. And observe here, this is not less than. This is not less than. Please, what is that? This is a subset or equals to. Subset or equals to. Okay, now. And observe here, bi subset or equals to ai intersection bj.
AI intersection is.
ai intersection bj, ai intersection, and bj equals to, we can write aj minus, this is the aj minus, or aj intersection a bar, a1 bar, a2 bar. So generalize this one. So ai intersection aj intersection and so on. Observe here somewhere here ai bar, and clearly ai bar, ai intersection ai bar for any set ai intersection a bar is always empty, and empty intersection of any set is always empty. And observe here, therefore this is every subset of this one is empty set. Therefore this is a superset. And observe here, superset is empty. Therefore automatically bi intersection, this is not bi intersection bj is empty set for every disjoint, for every element, okay, for every element. Therefore hence the theorem. Next theorem is given class of subsets of theorem 6 కూడా proof చేశాం చూడండి సార్ previously. Implies their finite arbitrary union is also belongs to A. And next page number 6 also proved.
Fifth theorem, sir.
Sixth one proof చేసిన చూడండి, పైన చేసాం చూడండి. The collection of A sets are said to be sigma algebra Borel field. Then their arbitrary union is also. B is a sigma containing C. B1 I consider different. Given any theorem number 5, page number 6, theorem number 5. Theorem number
Given
5.
any class C of
Given
subset of X, there is a unique smallest.
I considered a different way. In B1, you consider B dash 1. Sigma algebra containing C. Okay, no?
Okay, sir.
Just observe this one. And given that sigma is given that this is the so that C is subset of P of X, where P of X is the power set of X, power set of X, and power set of X is the sigma algebra. It follows there exists at least one sigma algebra containing class A. In other words, let tau be the collection of all sigma algebra of sets containing C, and collect the what is the tau equals to tau is any set of A's. Set of A means the set is a sigma algebra of sets in X such that the set containing C. Therefore, P of X subset of belongs to X. P of X is a sigma algebra and containing C any collection of subsets of X. And the tau is non-empty set. Not equal to empty means is a non-empty. Therefore, intersection B of members of this collection is well defined. That means B sets of B members is equal to, we can write, what is that? Intersection of A's, subset of what is this set containing C only. A is a sigma algebra. Now we prove that A is the smallest sigma algebra. Okay, now smallest sigma algebra containing C. First we prove that B what is that? B equals intersection. B is the sigma algebra, that is intersection of any class is of a sigma algebra is a sigma algebra is a class of sigma algebraic sets. Total set of all sigma algebraic sets. The collection of all here. What is a? Don't confuse here. What is a collection of sets? Collection of sets A1, A2, A3, A4 are all are collection of sets. Is a sigma algebra means what is that? We can collect any element, any set that complement is also belongs to that set, and finite arbitrary union B is also belongs to. Here what is the collection? The collection of all sigma algebraic sets. Okay, na? Sigma algebraic sets. The set of all sigma algebraic sets. Okay, na? And E is belongs to the A alpha. A alpha means what is that? Not a single set. The collect A alpha is a sigma algebraic set. Sigma algebraic sets means A alpha is a sigma algebraic sets means this is a collection of collection of sets. That collection of sets is satisfying sigma algebra conditions. Okay, na? E belongs to A alpha means for each alpha, E bar also belongs to. Since A alpha is a sigma algebra, E belongs to for each. We can prove each E belongs to intersection A alpha. Therefore, E bar belongs to the intersection of A alpha. What about intersection of this one is again if EI is a sequence of sets in A. What is the one page is missing here? Just wait. Just wait. Anywhere. I will send after this one. Okay, no? And continuation in EI is a sequence of. So finally we have. Therefore, union of EN belongs to the intersection.
A.
And last law student, sir. Last law student, madam. So and therefore, sigma alpha belongs to delta means delta is index set. Delta means index set means nothing but counted numbers. 1, 2, 3, 4. Any possible A1, A2. So therefore intersection. Therefore B is the sigma algebraic sets. X is the intersection of class of sigma algebraic sets also, and B1 is the sigma algebraic sets, and B1 is contained in C1. Therefore B1 is a member of the class of whose intersection is B. Therefore, so B1 what is the superset of B only? Hence the theorem. I will send again this PDF. Okay, now.
Okay, sir.
Definitions. Definitions are very important. Definitions are very important. We have to revise and consider some examples to each definition better. And smallest sigma algebra be containing the class of G and round up the G, all open sets. Open sets. Observe here. Observe here. Round up this. Just roughly write down. Roughly write down. Just wait. So sigma algebra. What is that? G. This is the all open sets is called the class of Borel sets in. Is a class of all open sets only. Any member B. Any member B. What is that? Sigma algebra containing the class of B. This B containing the class of all open sets only. Any member B is called the Borel set in R. Okay, now. And what is the here theorem is the smallest sigma algebra containing the class of F all closed sets in R. Closed sets in R.
Theorem
Is
6, sir.
class
Theorem
of
page number
Borel
7.
sets.
Page number 7, theorem 6, sir.
Theorem yes 6. Theorem 6. Theorem 6.
Is it
And
important, sir?
observe here. And observe here. And the smallest sigma algebra containing the class of F of all closed sets in R is the class B of Borel sets. And observe here we have same the given for every theorem we should write what is the given information, what is that by using that given information prove what is that given information, write down first. Then now we prove that suppose B dash is the sigma algebra generated by the class of F closed sets in R. Now we show that, observe here, B dash equals to B only. Okay, now. So algebra containing class of F. F means what is that? Closed sets. Closed sets. Observe here, given this, what is a Borel set is? Borel set is any smallest sigma algebra B containing the class of all open sets. Every open set in that set is called the Borel set. And observe here, given that the smallest sigma algebra containing class of all closed sets. But we have a definition for only open sets. The class was the smallest sigma algebra containing all open set, that every open set is called the Borel set in R. That is a perfect definition. And in theorem, prove that the smallest sigma algebra same containing the class of all open sets, class of F all closed sets are in R. Now we prove that each class of B of Borel sets. Okay, now we have B is the smallest sigma algebra containing open sets. B dash is the class of closed sets. Observe here, underline here. This is a given information. We have a definition for open sets. Now we prove that what is that? B dash is the sigma algebra generated by class of closed sets. Closed sets. Now we show that B dash equal to B. Therefore, every smallest sigma algebra containing class of all closed set, every closed set is called Borel set. But we have a definition for only open sets. Open sets only. And observe just wait. Open sets only. And what is the complementation? Here complementation.
B dash
Set. And observe here, F is a closed set. This belongs to the F, our graph. Then its complementation. F bar is open. Therefore, is a Borel set clearly. Therefore, what is that? B. Here B is a open sets. Set of all open. Open set. Set of all open. This is its complement is set of all closed sets. Therefore, we have a definition for open sets only, and its complementation. Observe here Borel set. Therefore, open set is belongs to Borel set. Since B is a sigma algebra. Sigma algebra meaning what is that? Sigma algebra. We can consider B is a sigma algebra. Its complement, we can consider any element, some element in the form of F bar, and its complement is also belongs to B. Therefore, we can write F whole bar. What is that? Bar. F bar whole bar equals to double complementation. A complement whole complement equals to that set only. Therefore, F equals to F bar whole bar belongs to B. Therefore, we can consider any element, and showing that B is the sigma algebra containing F. And observe here. Just 2 minutes. Sorry. Okay now. Therefore, therefore F is subset of B only, showing that B is a sigma algebra containing closed set. And observe here, what is that? If you want to prove that, now we prove that in bracket, you write down here. What is that? If you want B dash equal to B means, what is that? B is a subset of B dash. Enough to prove that. And P dash is a subset of B only. If we consider any element, suppose here observation F is belongs to the capital F. F is a closed sets. By using complement is open, therefore automatically that belongs to the B only. And B is the sigma algebra. Sigma algebra means we have a conditions. We can consider any element in B. Their complement is also in E. Therefore, F equal to, we can write F double bar equal to F only, and observe this one. You can consider any element F which is also in B. Therefore, F is subset of B. Therefore, F is subset of B means showing that B is a sigma algebra containing F. Therefore, by the definition of B dash, we have any element B dash subset of. B dash means closed sets. Any closed set containing class of closed sets is also in containing what is the open sets. Okay, now B dash is subset of B. This is the equation 1. In bracket write down. We show that B dash equal to B. Enough to show that B dash is subset of B and B is subset of B dash. Okay, now, and observe here. This is one. Again, G is an open set, and its complement. What is that? What is the complement? Is closed. What is the closed set? Is belongs to F only. And the closed set belongs to F only, which implies G bar belongs to B dash. Since B dash is the sigma algebra, it follows that G equals to G double dash B dash only. Therefore, this shows that what is that? Observe here. Select any open set. Its complement is closed set. What is the closed set? G bar is belongs to the F, which implies G bar belongs to the B dash. Therefore, what is here? This is the equation 1. This is equation 1. Equation 2. From equation 2, and B dash equals to B.
From 1 and 2.
From 1 and 2, B dash equals to any theorem. In any theorem, if you want to prove A equal to B, set theory especially, not a numbers. Set theory. if you want to prove that A equals to B, enough to prove that any set. What is that? A subset of B and B subset are equals to A. If you want to prove A subset of B means select any element A by using given information which is also in B. If you want to prove the A subset of B, any element select the A by using given information which is also in B.
B.
Could you prove that one? So arbitrarily chosen that element. Therefore, every element we can prove like this. Therefore, A is every element of A is also element of B. Therefore, automatically A is a subset of B. Clearly, okay, no? Clearly.
Yes, sir.
Just wait. Note that. Therefore, observe here the smallest sigma algebra containing class of all open intervals. Previous one sets, class of Borel sets. And observe here G delta set originally F sigma set, G delta set. Where it is, just wait. Any subset of R which is can be written as countable union of closed sets in R is called the F sigma set. Observe here G delta means open. Okay, now open. Previous one G delta set and which is a countable intersection of open interval is called the, and in page number 7, page numbers last definition students, sir. F sigma set. Just simply remember this one as F sigma set means countable union of closed sets F sigma set. Anywhere. G delta set, the countable intersection of open sets. What is the meaning of G delta? Countable
Open.
intersection of intersection of open sets is G delta set. Okay, now countable union of closed set is F sigma sets. This is a just wait. F sigma set. Every closed interval in R is an F sigma set. F sigma set means can we representation is countable union of closed sets. And every closed set in R, every closed interval. Observe one example 1 and 2. This is the interval is different, set is different. Every closed interval in R is a F sigma set. Every closed set in R a sigma set. Every countable set in R is also F sigma set. F sigma set. Examples here. Next, and observe here for 3. Every countable set in R, since any countable can be written as countable union of singleton sets of its elements, and singleton set is always closed. Singleton set is always closed. Therefore, can we write A equal to A1, A1, A2 containing singletons? Each what is a finite sets? Each finite set is a, what is a finite set is a closed or open? Closed set. Okay, now A equal to can be written as union of that sets. And countable. Any open interval F sigma set. What is the meaning of this one? And observe here. Any open interval can be written as union of closed intervals. What is the meaning of this one? Any open interval can be written as union of closed intervals. This is the open interval AB. Okay, now this is a closed interval A plus n by n equal to 1 union. N equal to 1 means A plus 1, A minus 1 union. N equal to A plus 1 by 2 closed intervals. Okay, now which is countable union of closed interval in R. Hence the countable union of closed sets in R, since every closed interval is a closed is a closed is a closed and okay now the countable in F sigma set is a F sigma set, the properties of F sigma sets only. Okay now, just which is a countable union of closed sets, a class of F sigma set is by G delta set here. Countable intersection of open set, G delta set, we have a definition. G delta set, A is a class of open sets, just revise. And in your book page number 8, 1.7, this is a everywhere better example of, this is a open interval. Are you observing?
Yes, sir.
That is everywhere.
Suppose
Any what is that?
Suppose IN is equal to is given.
Arbitrary intersection of open interval need not be a what is that, open. That is a better counter example. Arbitrary intersection of open interval need not be a, what is that for open? Finite union of open set is open. Arbitrary union of open set is open. But arbitrary finite intersection of open set is open. But arbitrary intersection of open need not be open. Better example is this one. Better example, open interval minus 1 by n comma 1 by n. Just wait. Okay, just observe all these definitions. F sigma. Again we can define G delta set, F sigma set, and observe here, just wait. F sigma delta. F sigma delta means, what is that? Collection of all countable intersection of members of F sigma. What is the F sigma means? F sigma means closed set. The collection of all countable intersection of closed sets. Correct enough?
Yes, sir.
Countable union of F G delta, D delta sigma, collection of all countable union of members of D delta. Okay, now similarly we can define what is that? F sigma, delta sigma, and so on like this. Okay. Next, set to definition. The main Lebesgue measure, Lebesgue outer measure. And a set function which is assigned to extend to the real number sets. The set function is, this is, observe here, the year mapping is any set and natural number set positive only, and their lengths is mappings to the, okay now, the real valued function is minus infinite to infinite. Okay now, just class of a finite and observe here, a finite interval, the endpoints where a comma b is defined to be, length of the interval is b minus a. I is not finite means infinite interval, L of I, length of interval is infinite. is the length of interval as following properties, and always length of the interval is positive. First one, length of union of two intervals is less than or equals to length of first I interval, length of j interval. Okay, now, and suppose I interval subset of j, their length is less than or equals to length of I plus alpha is equals to same. Just observe this one. What are the main properties of length of the interval? Union, the length of the union, length of I plus length of j, length of j. Okay, now length of I plus alpha. Remember this one. Okay, now for every alpha belongs to R. Measurement. There is no other meaning for the measure. Measure of means length only. What is that? Measurement of the set of a function m assigns to each some collection mu, set of a real number to the non-negative extended real numbers. Okay, is called the measure of, and we denote m of e, measure of length of the interval. Observe here, length of the interval. Just remember, measure means measure on measurement. Length of the interval in mathematically in measure and integration. What is that? Length of the interval only. The meaning of measure of. Okay, now me is defined for each set E of R for any interval I. For interval case, this is the one. What is that? A set of a function f assigned to be some collection of mu. Mu means measure of that set. We have classification is different. Especially, what is that? Interval is interval for interval. What is that? L of I, length of the interval only. Measure of that interval means length of the interval. And observe here is a sequence of designed sets. The measure of their union is equals to summation of measure of En. This is a countable additive measure. Here previous one we have a countable additive property. Countable additive measure here. Okay, the sequence of designed sets, then the measure of union of arbitrary union is equals to the summation m of En. Next, translation invariant. Observe measure of E plus X, any set is equals to E only, m measure of E only. Previous one. Length of the interval. What is that? Length of the union of interval less than or equals to same here. Length of the interval I plus X is equals to length of I only. Therefore, and observe here, E plus X means adding the A plus X to each element in A. So suppose any sets A subset, this is not less than. Please make it. What is that? Small bending here is not less than. A subset of B is, which implies measure of A is less than or equal. This is less than or equals to. This is called the monotonicity. Translation invariant. Previous one countable additive measure. And if there is a set in A such that what is that measure is m of A is measure is less than, always any real subset of real number set measure is always finite. What is that? Measure of A less than infinity, not alpha, that one. Measure of A less than infinity. What is the meaning of that one? What is the meaning of that one? X less than infinity, that is finite value. The measure of empty set is 0 always. The keywords in the measure and integration. Keywords. What is that? Translation invariant and monotonicity, countable additive property, open set, length of the interval, length of the, what is that? Closed interval, open interval. These are the main keywords in measure and integration. And observe here outer measure clearly. Observe here outer measure. Outer measure is ABA. Any subset of R is countable collection of open intervals. Open intervals in R is said to be covers A. Cover topological space, A covers B means, what is that? A covers B means A is a subset of some union of, what is that? Countable union of In. What is that? This collection is covers the A. This collection is covers the A means, what is that? A is a subset of the, what is that? Union of In only. This collection In covers, covering. So covering our friend, covering under same definition. So the union of ions covers the A. For each such collection, consider the sum of the lengths of the interval. So there exists not only one collection. What is that? If we want to cover the A, any set A, we can different open countable collection In intervals. Okay, now observe here clearly. The open covers for A, there exists more than one open covers. There exists a number of covers. Number of covers means there exists one collection In which covers A, another Jn collection which covers A. So like that, the collection of consider the sum of the lengths of the interval only. For this, especially this collection only. And observe here. And the infimum of all sums taken overall covers. Observe here, covers underline. This is a one cover length. Suppose what is that? Summation of in cover for A. That cover means the usual definition A. And one of the Jn cover, one of the cover Kn cover, and Kn cover, and so on. These are all the covers of open covers of A only. For this cover, find out the summation of I, length of In. What is that? Length of In. Summation of length of Jn. Summation of length of Kn. Therefore, we have some values for summation of length of In, some value length of summation of Jn, length of summation. From these all covers, find the infimum. All such sums taken overall covers of A is called the outer measure. Clear? So outer measure is there exists a open cover open intervals which covers A set. If you want to define outer measure of A set, there exists some covers. Find out the each cover length, each interval, and consider summation of length of In intervals here, and more summation of length of Jn intervals, and length of summation of length of, will get here some values from all these covers. Summation of all the lengths of these intervals, consider the infimum value, that is called the outer measure of A. Infimum of all such sums taken overall covers of A is called the outer measure of A, and it is denoted by, what is that? M star of A. Just roughly write down. M star of A. M of A means just length only. M star of A, infimum of In with a countable collection of open intervals such that countable collection covers A. Just roughly write down. Your meaning is like this. Observe infimum of summation of lengths In with a countable collection of open intervals that covers A. The outer measure of the finite what is that? Empty set is 0 always. Outer measure of singleton set is 0. Outer measure of finite set is also 0. We have a number of conditions, some properties. Outer measure of empty set is 0. outer measure, therefore, and non-negative. The theorem is non-negativity. Outer measure is always positive. Monotonicity, same monotonicity. A is a subset. Clearly write down, everyone. A is a subset. Measurement is less than or equal to 0. Yes, smoothly bending here, strictly bending, immediate bending, strictly. Translation invariance. Okay, no? Translation invariance. Just roughly write down. M star of E is greater than or equal to 0, non-negative. 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 Okay, no? Just proof. The since outer measure is the infimum of set of is non-negative numbers. Infimum means what is the infimum, supremum? So infimum set of non-negative numbers. Non-negative numbers. Okay, no? Here charging of this one is over. We'll continue tomorrow in next class. Okay, hello sir. Hello.
Yes, sir.
Hello.
Sir.
Sorry, are you getting measurable sets? Everything we have. Definition I
Yes,
wrote.
sir. Yes, sir.
Just I wrote yesterday this only. కాకపోతే బుక్ లో కొంచెం జిగ్జాగ్ ఉన్నాయి కాబట్టి మళ్ళీ రాశాను ఇవి.
Yes, sir.
ఓకే, నాకు బెటర్ యూ సెండ్ ది వాట్ ఇస్ దట్ ప్రీవియస్ క్వశ్చన్ పేపర్స్. మీరు క్వశ్చన్ పేపర్ సెండ్ అవి చేస్తే నాకు టైం ఉన్నప్పుడు అలా క్వశ్చన్స్ అన్ని నేను నీట్గా రాసి పెడతాను. ఓకేనా, విల్ డిస్కస్ అబౌట్ ఆల్ ఇంపార్టెంట్ క్వశ్చన్ అట్లీస్ట్. అన్ని రాయలేను.
Okay, sir. Okay.
ఓకేనా, ఇంపార్టెంట్ గన్ షాట్ క్వశ్చన్స్ ఉంటాయి కదా, అవి ఒకసారి డిస్కస్
షార్ట్ టైం
చేస్తే
అవే యూజ్ అవుతాయి సార్. ఈ షార్ట్ టైం ఉంది కదా సార్, షార్ట్ టైం లో అదే యూజ్ అవుతుంది.
అదే నేను చెప్పేది అదే. అందుకే మీరు ఒకసారి నాకు ఇంపార్టెంట్ క్వశ్చన్స్ రాస్తే నేను ఒకసారి మళ్ళీ రాస్తాను క్లియర్గా. ఓకేనా, క్లియర్ రాస్తాను. ప్లస్ ఇంకోటి ఏంటంటే ఏది ఇంపార్టెంట్ టాపిక్ అనేది మనకు తెలిసిపోతుంది. అవే మెయిన్ డెఫినేషన్స్, మెయిన్ థియరమ్స్ ఎక్స్ప్లెయిన్ చేసిన తర్వాత రిమైనింగ్ we have any time we will discuss about that. First of all, important topics, important definitions, important theorems discuss చేస్తే బెటర్ ఉంటుంది, మై ఒపీనియన్.
Oh, yes, sir.
Okay,
Okay,
sir.
sir.
ఓకేనా, లేదు అంటే కంటిన్యూస్ చేయండి. కంటిన్యూస్ అంటే కంటిన్యూగా పోతే క్లాస్కి ఒకటి థియరం 2 థియరమ్స్ అవుతాయి, మీకే ఇబ్బంది అవుతుంది.
అవును సార్, అవును.
ఎందుకంటే ఇది ఏంటంటే స్టార్టింగ్
ఫస్ట్ ఇంపార్టెంట్ చెప్పండి సార్.
అదే ఫస్ట్ ఏంటంటే జస్ట్ మెజర్ అవుటర్ మెజర్ వరకు ఓకే సార్. అవుటర్ మెజర్ వరకు ఓకే. అవుటర్ మెజర్ వరకు కంపల్సరీ ఇవన్నీ డెఫినేషన్స్, బేసిక్ డెఫినేషన్ నేర్చుకుంటే ఈజీ అవుతుంది. ఓకేనా, అవుటర్ మెజర్ ఎంటర్ అయిన కొన్ని ప్రాపర్టీస్ చెప్పేస్తాను. ఆఫ్టర్ దట్ టు డిస్కస్ ఓన్లీ మేజర్. వాట్ ఇస్ దట్ ఇంపార్టెంట్ అండ్ ఈజీ ఏమున్నాయో అవే చెప్పేస్తారు. ఓకేనా, అండ్ పార్ట్ 2 ఎల్పి స్పేస్ ఈజీ ఉంటుంది ఆటోమేటికల్లీ. హలో
సార్
హలో సార్.
చెప్పండి.
హలో.
పార్ట్
ఇంపార్టెంట్ చెప్పండి
ఎల్పి
సార్.
స్పేస్ ఉన్నాయి కదా
సార్
ఎల్పి స్పేస్ లో ఒక 2-3 థియరమ్స్ వెరీ ఇంపార్టెంట్ ఉంటాయి. అవి ఈజీ ఉంటుంది.
ఓకే సార్.
ఓకేనా, మెజరబుల్ ఫంక్షన్స్ ఒకటి అసలు ఒకసారి అందుకే నాకు పంపండి. నాకు ఒకసారి పంపితే నాకు టైం ఉన్నప్పుడు చేసి మీకు పంపించేస్తాను. ఓకేనా
సార్ ఎట్లా పంపుతారు సార్ అది?
మీకు గ్రూప్ లో పెట్టేస్తున్నా కదా పీడిఎఫ్.
సార్ ఇది అందరికి ఉన్న గ్రూపే కదా సార్, మెల్ల వేరే సపరేట్ ఉందా సార్?
అది పీజీ మ్యాథ్స్ గ్రూప్ లేకుంటే సార్ అది అంబేద్కర్ గ్రూప్
ఏమో నాదైతే ఒకటి యాడ్ చేశారు మేడం. ఒకసారి చూడండి, నేను ఇప్పుడు పీడిఎఫ్ ఇది పెట్టాను.
ఓకే సార్. ఓకే,
ఇది పీడిఎఫ్ పెట్టానా నేను?
ఎస్ సార్.
పెట్టానా లేదు ఈ పీడిఎఫ్ పెట్టలేదు. ఇప్పుడు పంపిస్తాను చూడండి ఒకసారి.
ఒకసారి పంపండి సార్ చూస్తా.
ఓకే ఇప్పుడు
అది ఏ
పంపిస్తాను.
గ్రూప్ లో ఉంది సార్ అది?
అదే ఇది పంపుతాడంటే సార్ పంపితే తెలుస్తుంది మనకు మనం ఏ గ్రూప్.
ఓకే ఇప్పుడు పంపిస్తున్నా చూడండి, వచ్చేస్తుంది పీడిఎఫ్. లాస్ట్ టైం కూడా పీడిఎఫ్ పెట్టినాను కదా మీకు.
ఎస్ సార్, వచ్చింది సార్, వచ్చింది. ఇది
వచ్చింది కదా,
వచ్చింది.
పంపించినాను, ఇదే ఇప్పుడే పంపించినాను. ఎస్ ఆల్రెడీ పంపించిన, డెఫినేషన్ ఆఫ్ మెజరబుల్ సెట్స్ అని పంపించినాను. 9:30కే పంపించిన మీకు.
పీజీ మ్యాథ్స్ గ్రూప్ సార్.
MSc సెకండ్ ఇయర్ స్టూడెంట్
MSc second year.
BRAOU.
ఓకే సార్.
ఒకసారి లేకపోతే యాడ్ అవ్వండి మేడం అక్కడ. లేకపోతే
Okay,
మీరు మీకు ఏమైనా సపరేట్ గ్రూప్ ఉంటే అందులో నన్ను యాడ్ చేయండి, లేదు అంటే లేకపోతే మీరు అక్కడ పంపించండి, గ్రూప్ లో పెట్టేసేయండి. మీకు సపరేట్ గ్రూప్ ఉంటే ఏమన్నా. ఓకేనా?
ఓకే సార్.
ఓకే, థ్యాంక్ యూ ఫర్ ఆల్.
ఓకే, థ్యాంక్ యూ సార్.
Thank you, sir.